Solubility, Utme chemistry past questions 1978 to 1990. Let's jump right in. So I've got UME 1978 question number 43. We are told consider the solubility curves of three salts X, Y, and Z given in diagram. If each solution of the salt contains 200 grams and is heated to 100 degrees Celsius, which solution or solutions will deposit more than 100 grams of the solid when suddenly cooled to 0 degrees Celsius? Now, if you take a look at this graph, now each solution of the salt contains 200 grams, and if you look at X, when it is cooled to 0 degrees Celsius, it falls somewhere around here, and you can see that the difference is now up to 100, so X is way out of it. If you look at Y from 200 to below 100, that is more than 100 grams, so definitely Y is there. Then what about Z? Z, of course, from 200 to below 50, that is way more than 100. So it will deposit more than 100 degrees Celsius. Sorry, more than 100 grams. So that is option E. I've got option E. That is for that. The next question, UME 1982, question number 29. We're told 9.8 grams of solid potassium chlorate we added to 40 cubic centimeter of water and heated to dissolve all the solid. As the solution cooled, crystals of potassium chlorate started forming at 66 degrees Celsius. The solubility of potassium chlorate at 66 degrees Celsius is therefore. So we're looking for the solubility at this point. Now, for solubility, of course, solubility is going to be the mass of solutes that dissolve or that saturate 100 grams of the solvent. In this case, since the options are given in moles per dm cube, so that's going to be moles per dm cube. It can also be grams per dm cube, however you want to look at it. So that means this 9.8 grams of solid potassium chlorate, we need to get the numbers of moles in this man. So how do we get moles? We know that mole is what? Mass over molar mass. So we know the mass, we need to figure out the molar mass. The molar mass is gonna be for potassium, actually I think this is meant to be given because you're not supposed to memorize this stuff. So perhaps the person setting the question just missed this time around, but normally it's meant to be given to you. So for potassium, that is 39 plus chlorine is 35.5 for chlorine. Then for oxygen is 16. So there are 3 atoms there, so we have 16 times 3. So we figure this guy's out, then we'll be able to get our final answer. So I've got 16 times 3, that's 48, plus 35.5, that is 83.5, plus 39, that is 122.5. So I've got 122.5 grams per mole. That is for molar mass. So the mole is going to be the mass. The mass is 9.8 grams over 122.5 grams per mole. So that is going to be equal to 9.8. Okay, let me figure that out. 9.8 divided by 122.5, so that would be 0.08 mole, 0.08 mole. So that is for the mole, and the solvent is 40 cubic centimeter, so that means we need to convert this guy to dm cube. Now remember that 1 dm cube is 1000 cubic centimeter, so For us to convert this guy to dm cube, we need to divide by 1000. So that is going to be 40 divided by 1000. This is going to cancel this, and I will be having 0.04, right? That'll be 0.04 dm cube. So 0.04 cubic decimeter. So I've got that for that. So the solubility is now going to be equal to the mole, which is 0.08 divided by 0.04. So 0.08 divided by 0.04, that is equal to 2 mole per cubic decimeter. So that is option E. So I've got option E, which is for that. The next question, UME 1982, question number 34. We're told the solubility curve of a solid S, and the solid S molar mass is 160, is as shown below. Okay, 1000 cubic centimeter of a saturated solution of X at this is cool to 40 degrees Celsius. The weight of X crystallized will be, now from here at 80 degrees Celsius, the solubility is 0.4. At 40 degrees Celsius, the solubility is 0.3. Therefore, it will deposit the difference between this guy, which is going to be 0.1 mole. So we've got 0.1 moles now. The solubility is 0.1 moles per sorry, not per, it has deposited 0.1 moles, of course. Yes, that is, I'm talking about what it would have, what would have been crystallized out of it now, which is 0.1 mole. And now I want to get the mass. Now, since I know that mole is mass over molar mass, therefore the mass is going to be equal to mole times molar mass. The mole is 0.1. 0.1 mole has been crystallized times the molar mass, which is 160. So that is going to be equal to 16 grams, which is option D. Okay, the next guy is question number 37 of UME 1983. We are told 3.06 gram of a sample of potassium triiosochlorate 5 was required to make a saturated solution with 10 cubic centimeter of water at this temperature. The solubility of the salt at this is now for this question, now, like I said earlier, you see that they give you the relative atomic mass for each element, and that's the way it's meant to be. So like I said earlier, I'm pretty sure the person that said that question made a mistake, or it must have been the past question that I was actually copying this from. So we need to get the solubility in moles per dm cube. So how do we go about that? We need mole. Mole is what? Mass over, small m, that is mass over molar mass. The mass is 3.06 divided by the molar mass. We need to figure out the molar mass, and the molar mass is going to be potassium 39 plus 35.5 plus, that will be 16 times 3. And I'm pretty sure we figured this out earlier. I think that is 1.22. Let me just go check it out again. 122.5. That's 122.5. Instead of us wasting our time. So that's 122.5. So I have 3.06 divided by 122.5. So let me quickly figure that out. Now I've got 3.06 divided by divided by 122.5. So that will be equal to 0.025 mole. So I've got that. Now it's dissolved in 10 cubic centimeters. So we need to convert it to dm cube. That will be 10 divided by 1000. As you all know how to do this, this will cancel this, so I'll have 0.01 cubic decimeters. So I've got that for that. Then my solubility will now be 0.025 over 0.01, which is going to be this guy divided by 0.01, and that will be equal to 2.497, which is approximately 2.5, which is option C, which stands for correct. So the next question, 1986, question number 10. When 50 cubic centimeter of a saturated solution of sugar, molar mass is this, at this temperature was evaporated to dryness, 34.2 grams of dry solid was obtained. The solubility of sugar at this temperature is this. So since it's given the moles per dm cube, so we just need to figure out the volume for the solution, since we already know the okay, and also the moles. The mole is mass over molar mass, which is 34.2 grams divided by the molar mass is 342. So we quickly figure that out. Pretty sure that is going to be 34.2 divided by 342, that is 0.1, that will be 0.1 mole. So I've got 0.1 mole. Now for the volume will be 50 divided by 1000. So this guy cancels this guy, then we'll be having 0.05. 0.05. So the solubility is going to be 0.1 divided by 0.05. So divided by 0.05, that will be equal to 2, which I'm pretty sure is going to be in the next one, which is option D. That's for that. So UME 1986, question number 11. We're told in the solubility curve above, water at 98 degrees Celsius is saturated with potassium chloride and potassium chlorate. What is the percentage of potassium chloride impurity in the crystal formed when the solution is cooled to 30 degrees Celsius? Now, at 98 degrees Celsius, that should be somewhere around here. I'm pretty sure that's where the two curves meet. If you twist it all the way down there, I think that should fall around 56. I'm not pretty sure about that, 56 or 57. So the at 98 degrees Celsius, the solubility is 56 grams per 100 grams of water. So that is for that. I'm pretty sure if you're in the exam hall, you're doing your CBT, the graph will be a lot clearer than this. Is it's from the, as you can guess from the past question I extracted this from. So that is for that. Now at 30 degrees Celsius, at 30 degrees Celsius will be here. Now for potassium chloride, if you twist it all the way up for potassium chloride, you give it to somewhere around here. This is below 40. So for potassium chloride, that should fall around something like 38 grams per 100 grams of that. That is at 30 degrees Celsius. That is for that. And for potassium chlorate, if you take it, if you look at it somewhere around there, that should fall around the middle 5 or 6. So that would be, let's say, 6 grams per 100 grams at 30 degrees Celsius. So if you want to get for potassium chloride, the mass deposited for potassium chloride, that's going to be 56 minus 38, and 56 minus 38, that is going to be 8. Then very bold one, that is good, 4 minus 1, that is going to be 18 for potassium chloride. That would be the quantity that will be crystallized for that, since it's dropping in temperature. Now for potassium chlorate, that is going to be 56 minus 6, which is going to be 50 for potassium chlorate. That is going to be 50. So 50 plus 18, of course, that will be 68. So we have 68 of grams that will be, crystallized from this solution. So we've got this. But since we are looking for the percentage of the potassium chloride and that's crystallized, so that is going to be the potassium chloride, that will be 18 over the total 68. For that will be 18 over 68. That's the fraction. But since we are looking for it in percentage, so we've got to multiply by 100. And I'm pretty sure if you do that, I will be having 18 divided by 68, then times 100. So that will be 26.4. So I've got 26.4 grams. 26.4 grams. Actually, I have 26.47 grams. So that will be approximately 26.5 grams, which is option G. To the next question, which is UME 9089, question number 17. If in the graph above 1 cubic decimeter of a saturated solution of potassium chloride is cooled from 80 degrees Celsius to 30 degrees Celsius, the mass crystal deposited will be, so for 30 degrees Celsius, bam, I'm pretty sure that will be 5.0. For 80 degrees Celsius, take it there, 6. So 6 minus 5, that will be 1. So I've got one mole. The number of mole is 1. So, and I know that, okay, for that is mole is what? Mass over molar mass. So the molar mass is 39 plus 35.5. 39 plus 35.5, that is 74.3. So I've got 74.3. So 74.3, of course, the mass is going to be mole times molar mass, which is 74.3, and I'm pretty sure that is 74.5. Pretty sure it's probably because of one two thing there. So that should be 74.5. So that is for that, option C. The next question, UME 1990 question number 16. The solubility in moles per dm cube of 20 grams of copper sulfate dissolved in 100 grams of water at 180 degrees Celsius is, of course, 20 grams over 100. That is 0 will cancel 0. 2 near 1, 2 here is 5, 1 over 5, which is 0.2. Yes, 20. Oh, sorry, since it's per dm cube, so it's moles per dm cube. So that is, we need to look for the mole. The mole is mass over molar mass. I was thinking I could just get it in grams per 100 grams of water. I just saw that we're asking moles per dm cube. So please be careful too. So I've got mass. The mass is 20 divided by the molar mass. The molar mass is 63.5 plus 32 plus 4 bracket 16. So let me quickly figure that out due to the calculator that I'm using. 4 times 16 plus 32 plus 63.5, and that will be equal to 159.5. So I know the molar mass, so that will be 159.5. So I've got 20 divided by 159.5, and that will be equal to 0.125 mole. Now I need to per dm cube, so that is just going to be 0.15 per dm cube. So since it's moles per dm cube, now I know that 1 gram per cubic centimeter, it's the density of water. So that implies that 1,000 grams is equivalent to 1,000 cubic centimeters. So 100 grams will be equivalent to cubic centimeter. So if I want to get this in decimeter, so I need to say 100 divided by 1,000. So I'm converting to decimeter. So this is going to cancel this, and I'll have 0.1. So the solubility is going to be 0.125 divided by 0.1. So divided by 0.1, that will be 1.25. So I've got option C, which is 1.25 moles per dm cube. And I think that's the end of the question. Like I said earlier, my name is SB Sanni, and you can check out our website for more questions. God bless us. Later.